The secondary standard is something like sonic master flow. It has sonic nozzles inside. We can very precise and very fast condition different airflows and use this for calibrate devices. In our own laboratory, we use two sonic master flows. In our China laboratory, we have two sonic master flows. And this is equipment for making customer-specific calibrations. But several customers in the field also use them to test their product because of the very, very fast airflow conditioning and the high precision. It has a big advantage. For example, hot wire flow meter calibration, HFMs. They measure the airflow which gets sucked by the engine into the car. And 100% of them have to be calibrated. In the former time, we have built a huge machine for the OEM, and some second equipment suppliers, some spare part suppliers from Asia, they use a SMF for it. It's a nice solution because of the speed, as mentioned before. And then we have the working standards. The working standards are delivered all over the world to all kinds of customers. So when you want to make some filter test, to detect when is the filter blocked, what is the filter performance, endurance test with filters, for example, we built the working standards. These are nozzle systems. They can very fast supply a certain amount of air. They use a sonic critical nozzle, which is shown on the top left. Sonic nozzle is using a certain principle. So the air can maximum flow with sonic speed. That's why it's called a sonic nozzle. Air cannot go faster. And if you have the shape of the sonic nozzle, and if you reduce the cross-section, what is happening there? When the cross-section gets smaller, the air needs to flow faster. At a certain point, no more volume can go through this sonic nozzle, through this tube. When this happens, the nozzle is critical. We call it in German critical. And that means no more air can go through. You can determine a certain pressure ratio between inlet and outlet. And when this certain pressure ratio is reached, without measuring anymore, you know what is the volume flow. And that is the high advantage of the sonic nozzle. Because at a laminar flow element and at a Venturi nozzle, you need to measure the differential pressure. And based on the differential pressure, you can calculate the volume flow. But on a sonic nozzle, I don't need to calculate the flow because I know it. I only need to check, is the nozzle right now critical? So is the difference between inlet and outlet in a certain range? And if so, automatically I can tell you 20 cubic meter per hour or whatever. And our nozzle systems, our sonic master flows, use this principle in a very, very elegant way. We order binumerically nozzles in a rising order. So that means, for example, the smallest nozzle is 2 cubic meter per hour. The next nozzle will be 4 cubic meter an hour. And the next will be again 8 cubic meter an hour. If I want to make now 10 cubic meter per hour, I open the nozzle with the 8 and the nozzle with the 2 cubic meter per hour. Then I have 10. If I want to have 16 cubic meter an hour, I also open the nozzle with the 4 cubic meter an hour. So additionally, now all nozzles are open. Let's assume it's a 3 nozzle system. Then I have 14 cubic meters an hour. And we can do that in all kinds of sizes. So we can, the SMF 6500 is our biggest one, which can hold the most nozzles inside of the system. And the SMF 100 is the smallest one. The nozzles can be custom made by us. So we manufacture them according to your requirement. The housing is a standard. We always build the same housing, but the nozzles inside of it we make customer specific for your demand. Here you see the Sonic Master Flow a little bit closer. It's easy to use. You just use our standard software. As mentioned before, we use it for all our calibrations in all our laboratories because of the 2 big advantages. Very, very fast airflow control and very high precision. This is how it looks inside. The big sonic nozzle drum, where all the nozzles are installed inside. It's a very repair-friendly system. So when there is any problem with the sealing of a nozzle, you only need to open some screws, move the system away. It has already the gliding path installed in our design. So it's very, very easy to maintain. At other customers or at other products, you need some cranes, you need a lot of engineers per hours to make service. But here to access the nozzles is fairly easy because of our well-designed system. And here we see now again a sonic nozzle in a little bit more detail. As it's said in the text, when the critical flow ratio is reached. So this means between inlet and outlet. The inlet is on the left, PA, absolute pressure sensor, and the outlet is on the right, PA. And we measure both pressures, and when a certain ratio is reached between inlet and outlet pressure, we know that the critical pressure is reached, and we know exactly that now sonic speed is inside and tell you what is the volume flow. And this is also the reason why it's so fast to control or to adjust. We open the valve, the pump is running on a certain performance, we open the valve, and directly the air goes through this maybe additional nozzle, and directly the new flow point is achieved. We only wait for a little bit so that the temperature is stable and the airflow is stable and some turbulences are gone. And then you can record the data of your test piece and the next calibration point is done. Very fast, very reliable. And because our flow determination is not depending on the precision of a sensor, normally you need a differential pressure sensor to determine the volume flow, but here not. It's also not so critical for service. You don't need a specific company to make your airflow calibration. You only need a company to make your pressure, temperature, and humidity calibration. That is another big advantage. The system has less likelihood to get in a certain uncertainty. And the big advantage that there are many suppliers for absolute pressure calibration, temperature calibration, and humidity calibration. you can disassemble the sensors and you can send it to them. But flow calibration, it is sometimes not so easy to either find a good supplier or disassemble a flow measurement unit and send it to the supplier, because you have effects in your system. It's called the measurement chain, and it's always the best to calibrate an airflow measurement device inside of the system, because maybe you have a bend and then you have your airflow measurement device and you only disassemble the device and send it to the laboratory. And when you get it back, this device is of course very precise, but the bend is affecting the airflow in a different way as at the service provider in his laboratory. Or maybe your device, your measurement device, is very sensitive to a certain pressure when you fix it in your machine, and now it measures wrong because you altered the environmental parameters compared to the entity who made the calibration. Therefore, for airflow, the best is always to calibrate it in the machine. With a sonic nozzle, you don't have this problem, because the airflow does not need to be calibrated so regularly. The sonic nozzle is a piece of steel with a hole in it, in a very abstract way. What should change there? If you don't put sand through the system, the sonic nozzle will not, if you don't put oil with dust through the system, the sonic nozzle will not change its diameter, it's metal. The sensors you can disassemble and send to laboratories, the pressure, temperature, and humidity sensors. By that, you can ensure the quality of your system without the need of a service provider of airflow calibration. This is a big advantage which I encounter with many customers in Asia. And here we can see again the minimum flow and the maximum flow of the SMF. If you want to check it in detail, just pause the video and look for it. And if you think, oh, something like this could be interesting for me, just send us an inquiry. And I just noticed that our maximum flow is the biggest system is the SMF 10,000 and not 6,500. So we can go from 2 to 10,000 cubic meter an hour with 16 nozzles. And accordingly for the other systems. And here on this page, you can see the sonic nozzle sets. So as mentioned before, I studied IT, so maybe you notice something. It's binumerically ordered, exactly how an integer number is stored in the computer, with 1 and 0 for each position. We do that because, similar to integer, the smallest unit, if you take little endian, the smallest unit is determining your step size. In this example, the smallest nozzle is 2 cubic meter an hour, and we order it binumerically. So therefore we can make now steps in 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on. I want to give this really long example because sometimes it's not so logic, but how can I make 6 cubic meter an hour, or how can I make 14 cubic meter an hour? Well, 14 cubic meter an hour, you open nozzle 3, 2, and 1. Then you have 8 plus 4 plus 2, which is 14 cubic meter, that's it. If you want 16 cubic meter an hour, you close nozzle 3 to 1 and you open nozzle 4, and so on. Why do we only have 1000 cubic meter an hour? But if we sum up all the flow points, we get a value higher. than 1000 cubic meter an hour. The reason is at a bigger flow point, we cannot use the smallest nozzles anymore because the smallest nozzles need a higher pressure difference and they cannot be used when you need a big volume for the big flows. So therefore, the sum of all nozzles would be higher as 1000 cubic meter an hour, but because the smallest nozzles cannot be used, it is 1000 cubic meter an hour in this example. The accuracy is between 0.3 or 0.2%. It depends on your demand. We can either supply it as the PTB version, which is the most precise version, or the DAX version. And here you can see the setup of the system. We can have it either as a standard setup or with a full data acquisition. As mentioned earlier, with the full data acquisition, we can measure all data which is there. We can read the test piece, we can read your component. We can maybe also make an adjustment of the values, so we can reconfigure it. We can make the checkup and give green light. By that, it is a fully automatic calibration system. This is good if you are a standard manufacturer of components. For laboratories, it's not so needed because every test piece is different, so you don't connect directly on the test piece. But if you are a manufacturer which wants a fully automated, fully integrated test system, we make the option 2. The user only has to press the start button, the system makes all the rest, and the finished adjusted device comes out of the system. And here you can see the scratch, how it's designed. On bigger again, on the right, you can see the vacuum pumps. In this example, we need 2 vacuum pumps because it is such a big sonic nozzle system that the performance of one is not enough. They are directly connected to the nozzle system and the unit under test. The test piece would be on the left, connected to our system. On this page, you can see the software. As mentioned before, the 2 separate vacuum pumps, which can be controlled through the user interface. You can open the nozzles either by hand, as you need them, or by the fully automatic test plan, which is opening the nozzles accordingly so that the intended airflow is there. Here you see such a test plan. You configure which nozzles should open. You say what volume flow you want. You give it a name. This is done by the setter. And the user can start the test plan and the system will do the measurement. It has an automatic leakage test. As mentioned before, adjustment for calibration parameters. So you don't need to come to our company for calibrating it. The software is completely open. You go to any third-party supplier in the field and make the calibration, make the checkup. It's easy to dismount, also as mentioned before, and it has a diagnostic screen. And here also our Android app is very helpful. When you need to make a service on the equipment, you just connect your mobile phone with our system. You can control all the channels by hand and have the advantage that no one needs to stand in front of it. You can work at the back of the system, use your phone to open some valves and close some valves, and you will see and you will have directly the control of them and you see the effects. This is very nice for troubleshooting, done by us, in-house developed, can be used by you. And here it is very important to mention, we do everything for you. When you need a custom specific adjustment, when you need another design, when you want to have a fixture, whatever you need, come to us, tell it to us, and we will redesign our equipment so that it fits for your purpose. We collaborate really strong with the PTB. That's why we also have these two versions. The more precise version is the PTB version because they need to make the calibration for us. The DAX version is built completely in-house and calibrated in-house. Here are some applications for the system. Like mentioned in another video, it can be either used for HFM, hot wire flow meter calibration. The hot wire flow meter is the component in the car which is measuring the air inflow. You need to know this air inflow to the car so that you can adjust or that you can mix it with a certain amount of fuel for the perfect combustion, for the perfect relation to each other. Therefore, you need this HFM, and every component has to be calibrated. This can be done by a sonic nozzle bench, an ultrasonic flow meter, a rotary gas meter. Actually, whatever kind of meter you manufacture or whatever kind of device if air is going through and you want to measure something, you want to calibrate something, you can use a sonic nozzle system. To wrap it up, the SMF test bench is a modular design. It has different flow ranges, different options, depending on your demand. It is very precise, long-term stable. I think I explained that in very detail. Comfortable to use with our software and easy to service because of our design. That is the good thing. We have such a sonic nozzle system in Germany in our calibration lab, actually 2 of them. We have 2 of them in China, so we use them a lot. And we don't like to use equipment which is not on our level of standard. Therefore, it is really good to make the mechanical service, and the software is perfect. This was a short introduction to our company. Now I would like to recommend you to watch our image movie. We will link it at the end of this video. It gives a nice introduction. It shows you how our company developed. It shows you all the different fields of the engineering sector, how we built your product, how we built these really nice machines and this really nice equipment. And it's quite nice to consume. I hope that you follow some more videos about, for example, how the different measurement systems work. What is the difference between an LFE, a Venturi nozzle, or you go directly into a nozzle test system, into the bell prover system. Just follow our channel and experience our skills. Thank you very much for your time and have a good day. Bye bye.